Picture this, a world untethered, drifting silently through the endless void of space. No sun to warm its surface, no star to guide its path. These are rogue planets, lonely wanderers of the cosmos, adrift in the infinite darkness. Imagine the silence, the stillness, the sheer vastness of their journey. What secrets do they carry? What stories could they tell? Tonight, as you close your eyes and let the universe unfold around you, we'll embark on a journey to uncover the mysteries of these enigmatic worlds. Together, we'll explore the cold, dark expanse where rogue planets roam, and perhaps, just perhaps, we'll catch a glimpse of the wonders that lie hidden in the shadows of the cosmos. So, wherever you are, whatever time it is, let's step into the unknown and discover the allure of these starless worlds. The universe is waiting. Now, let's take a closer look at what rogue planets truly are. Unlike the planets we're familiar with, those that orbit stars like our sun, rogue planets are cosmic nomads, untethered from any star. They drift freely through the vast expanse of space, unbound by the gravitational pull of a parent star. But how do these wandering worlds come to exist? One possibility is that they were once part of a star system, just like Earth or Jupiter, but were violently ejected due to gravitational interactions. Imagine a cosmic game of billiards where planets are knocked out of their orbits and sent hurtling into the void. Another theory suggests that some rogue planets may have formed on their own, born from collapsing clouds of gas and dust in the cold, dark regions of interstellar space, never knowing the warmth of a star. What makes rogue planets so fascinating is their independence. Without a star to illuminate them, they exist in perpetual darkness, their surfaces bathed only in the faint glow of distant starlight. This lack of a host star also makes them incredibly difficult to detect. Traditional methods of finding planets, like observing the dimming of a star as a planet passes in front of it, simply don't work here. Instead, scientists rely on techniques like gravitational microlensing, where the planet's gravity bends and magnifies the light from a background star, revealing its presence. Even then, spotting these elusive worlds is like finding a needle in a cosmic haystack. Their solitary nature and the challenges of detection only add to their mystery, making rogue planets some of the most intriguing objects in the universe. Now, let's journey back in time to uncover how these mysterious rogue planets were first discovered. The story begins in the early 2000s, when astronomers made the first confirmed detection of a rogue planet. This groundbreaking discovery was made possible by a technique called gravitational microlensing, which relies on the way a rogue planet's gravity bends and magnifies the light from a distant star as it passes in front of it. It's like a cosmic magnifying glass, revealing the presence of an otherwise invisible world. This method opened up a new window into the universe, allowing scientists to spot these elusive wanderers for the first time. One of the key figures in this field was a team of researchers led by astronomer Anders Udalski, who played a pivotal role in using microlensing to identify rogue planets. Their work, combined with data from missions like the Optical Gravitational Lensing Experiment, or OGLE, helped pave the way for future discoveries. Over time, advancements in technology, particularly in infrared telescopes, have further revolutionized our ability to detect these dark, cold worlds. Infrared telescopes, like the James Webb Space Telescope, are especially well suited for this task because they can pick up the faint heat signatures emitted by rogue planets, even in the absence of starlight. As our tools and techniques have improved, so too has our understanding of these enigmatic objects. Missions like the Wide Field Infrared Survey Telescope, or WFIRST, are set to take this exploration to the next level, promising to uncover even more rogue planets in the coming years. Each discovery adds a new piece to the puzzle, helping us better understand the origins and nature of these wandering worlds. From the first detection to the cutting-edge technology of today, the search for rogue planets continues to push the boundaries of what we know about the cosmos, reminding us just how much there is still to explore. Now, let's turn our attention to how these wandering worlds come to be. The formation of rogue planets is a fascinating puzzle, and scientists have proposed several theories to explain their origins. One of the most widely accepted ideas is that rogue planets were once part of a star system, just like Earth or Jupiter. But something dramatic happened. A gravitational tug of war, perhaps caused by a passing star or a collision with another massive object, flung them out into the void. Imagine a game of cosmic billiards where a planet gets knocked out of its orbit and sent hurtling into the darkness of space, never to return to its home star. But that's not the only way rogue planets can form. Some may have never had a star to begin with. In the vast, cold regions of interstellar space, clouds of gas and dust can collapse under their own gravity, forming planets directly. These planets are born in isolation, drifting through the galaxy from the very start. Think of it like a seed sprouting in the middle of a desert, growing into a tree without ever being part of a forest. These free-floating worlds are a testament to the incredible diversity of planetary formation. The process of ejection, or independent formation, isn't just a random event. It's shaped by the intricate dance of gravity. When a planet is ejected from its star system, it's often the result of chaotic interactions between multiple massive objects. Picture a crowded dance floor where one dancer gets pushed out of the group, left to move on their own. Similarly, planets can be sent on a lonely journey through the cosmos, untethered from any star. On the other hand, planets that form directly from collapsing gas clouds are like cosmic orphans, born without a parent star to guide them. These worlds are often colder and darker, but they carry the same potential for mystery and wonder as their star-bound counterparts. Whether they're castaways or loners from birth, rogue planets remind us that the universe is full of surprises, and there's still so much we have yet to discover about how these enigmatic worlds come to be. As we continue to explore the cosmos, each new discovery brings us closer to understanding the origins of these wandering worlds. And with every piece of the puzzle we uncover, we gain a deeper appreciation for the incredible forces that shape our universe. Now, let's follow these wandering worlds on their solitary journey through the cosmos. Picture a rogue planet, untethered from any star, drifting endlessly through the cold, dark expanse of space. It's a journey measured not in years, but in eons, a slow, silent voyage across the galaxy. Without the warmth of a sun or the pull of a star's gravity, these planets are truly alone, navigating the vast emptiness with only the faint light of distant stars to guide them. Their paths are shaped by the invisible hand of gravity, influenced by the pull of nearby stars, black holes, and even the subtle tug of dark matter. Some rogue planets may travel in relatively straight lines, while others could be flung into wide, looping orbits, weaving through the galaxy like cosmic nomads. Over billions of years, they might pass through star clusters, skirt the edges of nebulae, or even cross the paths of other rogue planets, though such encounters are rare in the vastness of space. Imagine the solitude of these worlds. No sunrise or sunset marks the passage of time. No seasons change the landscape. Instead, they exist in a state of perpetual twilight, bathed in the faint glow of starlight. The surface of a rogue planet, if it has one, might be frozen and barren, or it could harbor hidden oceans beneath layers of ice, kept liquid by the planet's internal heat. These worlds are a testament to resilience, enduring the harshest conditions the universe has to offer. Yet, despite their isolation, rogue planets are not entirely without purpose. As they drift, they carry with them the potential for discovery. Some may pass close enough to a star to be captured, becoming part of a new system. Others might collide with other celestial bodies, sparking new formations or even triggering the birth of stars. In their quiet way, these wandering worlds play a role in the grand tapestry of the cosmos. Their journey is a reminder of the vastness of space and the countless mysteries it holds. Each rogue planet is a story waiting to be told, a silent traveler in the endless night. And as we continue to explore the universe, we may one day uncover the secrets of these lonely wanderers, shedding light on their origins, their paths, and the role they play in the ever-evolving story of our galaxy. Now, let's shift our focus to a fascinating question. Could rogue planets, these lonely wanderers of the cosmos, actually support life? At first glance, the idea seems unlikely. After all, the traditional concept of the habitable zone, often called the Goldilocks Zone, revolves around a planet orbiting a star at just the right distance to allow liquid water to exist on its surface. But rogue planets, by definition, have no star to call home. So, how could they possibly harbor life? The answer lies beneath the surface. While a rogue planet's exterior might be frozen and inhospitable, its interior could tell a different story. Internal heat sources, such as radioactive decay or the gravitational tug of a moon, might generate enough warmth to create subsurface oceans. Think of it like the icy moons in our own solar system, such as Europa or Enceladus, which are believed to have vast oceans hidden beneath their icy shells. These oceans, kept liquid by internal heat, could provide a stable environment for life to thrive, even in the absence of sunlight. Tidal forces, caused by the gravitational pull of a moon, or even interactions with other celestial bodies, could also play a role. These forces can generate friction within a planet's core, producing heat that keeps water in liquid form. Imagine a rogue planet with a moon locked in a gravitational dance, constantly stretching and compressing the planet's interior. This process could create pockets of warmth, offering a refuge for life in an otherwise cold and dark environment. But what about energy? Without sunlight, how could life survive? Here, we turn to Earth's extremophiles, organisms that thrive in the most hostile environments, such as deep-sea hydrothermal vents. These creatures rely not on sunlight, but on chemical energy from the minerals and gases around them. A rogue planet with a subsurface ocean rich in minerals could provide a similar energy source, allowing life to emerge and evolve in ways we're only beginning to understand. This challenges our traditional view of habitability. Instead of looking for planets in the Goldilocks zone, we might need to broaden our search to include these dark, wandering worlds. Rogue planets could be hidden havens, their icy exteriors masking vibrant ecosystems beneath. As we continue to explore the universe, these enigmatic worlds remind us that life, in all its forms, might find a way to exist in the most unexpected places. And who knows, the next great discovery in our search for extraterrestrial life might not be around a star at all. It could be drifting silently through the void, waiting to be found. Now, let's turn our attention to the tools and techniques that allow us to uncover these hidden wanderers of the cosmos. Detecting rogue planets is no small feat. After all, these worlds drift silently through the darkness, emitting no light of their own. Yet, scientists have developed ingenious methods to spot them, each offering a unique window into the unseen corners of our galaxy. One of the most effective techniques is gravitational microlensing. This phenomenon occurs when a rogue planet passes in front of a distant star, bending and magnifying the star's light due to its gravity. It's like a cosmic magnifying glass, revealing the presence of an otherwise invisible object. While the effect is fleeting, lasting only hours or days, it provides crucial clues about the planet's mass and distance. This method has already led to the discovery of several rogue planets, offering a glimpse into their mysterious existence. Another powerful tool is infrared imaging. Rogue planets, though cold, still emit heat from their formation or internal processes. Infrared telescopes, like the James Webb Space Telescope, can detect this faint thermal radiation, allowing us to see these dark worlds. By scanning the skies in infrared wavelengths, scientists can identify rogue planets that would otherwise remain hidden in the void. This approach has opened up new possibilities for mapping the distribution of these solitary travelers across the galaxy. Direct observation, while incredibly challenging, is another method scientists are exploring. This involves capturing the faint light reflected by a rogue planet, often using advanced telescopes equipped with coronagraphs to block out the glare of nearby stars. Though rare, these observations provide valuable insights into the planet's atmosphere and surface properties, painting a clearer picture of its characteristics. However, detecting rogue planets comes with significant challenges. Their lack of a host star makes them incredibly difficult to locate, and their faint signals can easily be drowned out by background noise. To overcome these obstacles, scientists rely on a combination of cutting-edge technology and innovative data analysis techniques. Machine learning, for instance, is being used to sift through vast amounts of observational data, identifying subtle patterns that might indicate the presence of a rogue planet. Despite these hurdles, the search for rogue planets continues to push the boundaries of our understanding. Each discovery not only adds to the growing catalog of these enigmatic worlds, but also challenges our assumptions about where and how planets can exist. As our tools and techniques evolve, we inch closer to unraveling the secrets of these cosmic nomads, reminding us that the universe is full of surprises waiting to be uncovered. Now, let's take a closer look at one of the most fascinating tools in the hunt for rogue planets: gravitational microlensing. This technique has revolutionized our ability to detect these elusive worlds, and understanding how it works is key to appreciating its significance. Gravitational microlensing is a phenomenon rooted in Einstein's theory of general relativity. Imagine a rogue planet drifting through space, passing in front of a distant star. As it moves, the planet's gravity bends and magnifies the star's light, acting like a natural lens. This temporary brightening of the star's light is what scientists call a microlensing event. Even though the effect lasts only a few hours or days, it provides a wealth of information about the rogue planet, including its mass, distance, and even hints about its composition. What makes microlensing so effective for finding rogue planets is its ability to detect objects that don't emit their own light. Unlike traditional methods that rely on a planet reflecting or emitting light, microlensing works purely through gravity. This means it can uncover planets that are completely dark, drifting alone in the vast emptiness of space. It's like finding a needle in a cosmic haystack, but with a tool that's perfectly suited for the job. One of the most exciting aspects of microlensing is its ability to reveal planets that would otherwise remain invisible. For example, in 2016, astronomers using this method discovered a rogue planet roughly the size of Earth, floating freely in the Milky Way. This discovery was groundbreaking, as it showed that even small, Earth-sized worlds could exist without a star to call home. Another notable find came in 2018, when a rogue planet with a mass between Earth and Neptune was detected, further expanding our understanding of these solitary worlds. The beauty of microlensing lies in its simplicity and power. It doesn't require the planet to be close to us or to emit any light. It simply relies on the natural interplay of gravity and light. This makes it an invaluable tool for mapping the distribution of rogue planets across the galaxy and understanding their origins. As technology advances and more microlensing events are observed, we can expect to uncover even more of these mysterious wanderers, shedding light on their role in the cosmic tapestry. By harnessing the power of microlensing, scientists are peeling back the layers of the universe, revealing a hidden population of planets that challenge our understanding of how planetary systems form and evolve. Each discovery brings us closer to answering some of the most profound questions about the nature of these solitary worlds and their place in the cosmos. Now, let's shift our focus to another groundbreaking tool in the search for rogue planets: infrared telescopes. While microlensing reveals these worlds through gravity, infrared telescopes allow us to see them in a completely different way, by detecting the heat they emit. Unlike stars, rogue planets don't shine with visible light, but they do radiate warmth, making infrared technology essential for spotting these dark, drifting worlds. Infrared telescopes are uniquely suited for this task because they can detect the faint thermal signatures of rogue planets. These telescopes capture the heat energy emitted by objects in space, even if those objects are too cold or distant to produce visible light. This makes them perfect for identifying rogue planets, which often have temperatures far below freezing, yet still emit enough infrared radiation to be detected. It's like using night vision goggles to see in the dark, except on a cosmic scale. One of the most exciting developments in this field is the James Webb Space Telescope, or JWST. Launched in 2021, this state-of-the-art telescope has already begun to revolutionize our understanding of rogue planets. With its advanced infrared sensors, JWST can peer through cosmic dust and gas, revealing details about these planets that were previously hidden. For example, it can measure the temperature and composition of rogue planets, giving us clues about their atmospheres and potential for harboring life. But JWST isn't the only player in the game. Other infrared telescopes, like the Spitzer Space Telescope and the Wide Field Infrared Survey Explorer, or WISE, have also made significant contributions. Spitzer, for instance, helped identify some of the first rogue planets by detecting their faint heat signatures. WISE, on the other hand, has mapped large areas of the sky, uncovering numerous rogue planet candidates that are now being studied in greater detail. What makes infrared telescopes so powerful is their ability to complement other detection methods. While microlensing provides information about a rogue planet's mass and distance, infrared observations can reveal its temperature, composition, and even potential weather patterns. Together, these tools paint a more complete picture of these mysterious worlds, helping us understand how they form, evolve, and interact with their surroundings. As technology continues to advance, infrared telescopes will play an increasingly important role in rogue planet research. Future missions, like the Nancy Grace Roman Space Telescope, are expected to expand our capabilities even further, potentially uncovering thousands of new rogue planets across the galaxy. Each discovery brings us closer to understanding the full diversity of planetary systems and the role these solitary worlds play in the universe. By combining the power of infrared telescopes with other detection methods, scientists are unlocking the secrets of rogue planets, one discovery at a time. These tools not only help us find these elusive worlds, but also deepen our understanding of the cosmos, reminding us just how much there is still to explore. Now, let's take a step into the realm of imagination and see how rogue planets have captured the creativity of storytellers. In popular culture, these wandering worlds have often been portrayed as mysterious and enigmatic, serving as the backdrop for tales of adventure, danger, and even hope. From science fiction novels to blockbuster films, rogue planets have become a fascinating canvas for exploring the unknown. In movies, rogue planets are frequently depicted as dark, foreboding places, shrouded in mystery and peril. Think of films where these worlds are shown as desolate landscapes, devoid of sunlight, where survival is a constant struggle. These portrayals often emphasize the isolation and harsh conditions of rogue planets, playing on our fears of the unknown. Yet, they also spark curiosity, inviting us to imagine what it might be like to explore such a place. Books, on the other hand, sometimes take a more nuanced approach. Science fiction authors have imagined rogue planets as not just barren wastelands, but as worlds with hidden potential. Some stories describe these planets as having subsurface oceans or geothermal activity, creating environments where life might thrive despite the lack of a star. These narratives often challenge our understanding of habitability, suggesting that life could exist in the most unexpected places. Interestingly, these creative depictions often blend scientific facts with imaginative leaps. While real rogue planets are indeed cold and dark, the idea of them harboring life isn't entirely far-fetched. Scientists have theorized that internal heat sources, like radioactive decay or tidal forces from moons, could create habitable conditions beneath the surface. This overlap between fiction and reality makes rogue planets an especially compelling subject in popular culture. Video games and other media have also embraced the concept of rogue planets, often using them as settings for exploration and discovery. In these virtual worlds, players can experience the thrill of navigating a planet without a star, uncovering its secrets and facing its challenges. These interactive experiences bring the science of rogue planets to life in a way that's both entertaining and educational. While popular culture tends to amplify the drama and mystery of rogue planets, it also reflects our fascination with the unknown. These stories remind us that the universe is full of possibilities, and that even the most isolated worlds might hold surprises. As we continue to study rogue planets, we may find that the line between science fiction and scientific reality is thinner than we think. With this blend of imagination and science in mind, let's turn our attention to another intriguing question. Could rogue planets actually support life? This brings us to the next chapter of our journey, where we'll explore the potential for life on these solitary worlds and what it might mean for our understanding of the universe. Now, let's shift our focus to one of the most captivating questions about rogue planets. Could these wandering worlds actually support life? At first glance, the idea seems far-fetched. After all, rogue planets drift through the cold, dark void of space, far from the warmth and light of a star. But when we look closer, the possibility becomes more intriguing, especially when we consider the resilience of life here on Earth. Take extremophiles, for example. These are organisms that thrive in some of the harshest environments on our planet, places where most life would struggle to survive. From the scorching heat of hydrothermal vents at the bottom of the ocean to the freezing temperatures of Antarctica's ice sheets, extremophiles have adapted to conditions that seem almost alien. If life can exist in such extreme environments on Earth, why not on a rogue planet? One key factor is heat. While rogue planets lack the warmth of a star, they might still have internal heat sources. Radioactive decay in their cores could generate enough warmth to maintain liquid water beneath their surfaces. Imagine vast, hidden oceans trapped under layers of ice, where geothermal activity creates pockets of warmth. These subsurface oceans could provide a stable environment for life, shielded from the freezing temperatures of space above. Another possibility is tidal heating. If a rogue planet has a moon, the gravitational pull between the two could create friction, generating heat within the planet's interior. This process, similar to what happens on Jupiter's moon Europa, could keep subsurface oceans from freezing and create conditions suitable for life. Even without a star, the interplay of gravity and geology might sustain habitable environments. But what kind of life could exist in such places? On Earth, extremophiles like bacteria and archaea thrive in environments with no sunlight, relying instead on chemical energy from hydrothermal vents or minerals in the rock. Similar organisms might flourish in the dark, icy depths of a rogue planet's oceans, using whatever energy sources are available to survive. Over time, these simple life forms could evolve into more complex organisms, adapting to their unique environment in ways we can only imagine. Of course, the idea of life on rogue planets is still speculative. Detecting such life would be incredibly challenging, given the vast distances and the planet's lack of light. But the possibility alone is enough to spark curiosity and drive scientific exploration. After all, if life can exist in the most extreme corners of our own planet, why not in the hidden depths of a rogue world? As we ponder this question, let's turn our attention to another fascinating aspect of rogue planets, their connection to dark matter. Could these wandering worlds hold clues to one of the universe's greatest mysteries? That's where our journey takes us next. Now, let's venture into one of the most intriguing mysteries of the cosmos, the connection between rogue planets and dark matter. Dark matter, that elusive substance that makes up a significant portion of the universe's mass, has puzzled scientists for decades. We can't see it, we can't touch it, yet its gravitational effects are undeniable. So, where do rogue planets fit into this cosmic puzzle? Some scientists have proposed that rogue planets could be part of the solution to the dark matter mystery. While dark matter itself remains invisible, rogue planets are tangible, albeit hard to detect. Could these wandering worlds, drifting silently through space, account for some of the universe's missing mass? It's a fascinating idea. Rogue planets, especially those that are small and dim, might be far more numerous than we currently realize. If there are billions or even trillions of them scattered across the galaxy, their combined mass could contribute significantly to the total mass of the universe. But how might rogue planets interact with dark matter? One theory suggests that rogue planets could act as gravitational lenses, bending the light from distant stars and galaxies in a way that reveals the presence of dark matter. This phenomenon, known as gravitational microlensing, has already been used to detect rogue planets themselves. If these planets are embedded in regions rich with dark matter, their gravitational influence could help map the distribution of this mysterious substance, giving us clues about its nature and behavior. Another intriguing possibility is that rogue planets could be influenced by dark matter in ways we don't yet fully understand. For instance, dark matter particles might accumulate around rogue planets, creating a kind of halo that affects their motion through space. This interaction could subtly alter the trajectories of rogue planets, providing indirect evidence of dark matter's presence. While this remains speculative, it opens up exciting avenues for future research. The connection between rogue planets and dark matter also raises questions about the formation and evolution of the universe. If rogue planets are indeed more common than we think, they could play a role in shaping the large-scale structure of the cosmos. Their gravitational pull, combined with the influence of dark matter, might help explain how galaxies and galaxy clusters form and evolve over billions of years. As we explore these ideas, it's important to remember that much of this remains in the realm of theory. The study of rogue planets and dark matter is still in its early stages, and many questions remain unanswered. But that's what makes it so exciting. Every discovery, every new piece of data, brings us closer to understanding the hidden forces that shape our universe. With this in mind, let's turn our attention to another fascinating aspect of rogue planets: their size and composition. How do these wandering worlds vary, and what does that tell us about their origins and potential for supporting life? That's where our journey takes us next. Now, let's take a closer look at the incredible diversity of rogue planets, from their size to their composition. These wandering worlds come in all shapes and forms, ranging from small, rocky planets, similar to Earth, to massive gas giants that dwarf even Jupiter. This variety isn't just fascinating, it also holds important clues about how these planets form, evolve, and potentially sustain life. At one end of the spectrum, we have Earth-sized rogue planets. These rocky worlds, often made up of metals and silicates, might resemble our own planet in terms of structure, but without a star to warm them, their surfaces are likely frozen wastelands, shrouded in perpetual darkness. Yet, beneath their icy exteriors, these planets could harbor secrets. Their rocky cores might retain heat from their formation, creating subsurface oceans or geothermal activity that could, in theory, support life. Imagine a world where life thrives not under the warmth of a sun, but deep within the planet itself, sustained by the heat of its own core. On the other end, we find rogue gas giants, colossal planets like Jupiter, or even larger. These behemoths are composed mostly of hydrogen and helium, with thick atmospheres that trap heat effectively. While they lack a solid surface, their immense size allows them to retain heat for billions of years. Some scientists speculate that their atmospheres could host complex chemical reactions, potentially creating environments where life, in some form, might exist. Picture a vast, swirling atmosphere with layers of clouds, where temperatures and pressures vary dramatically, offering niches for exotic forms of life to emerge. The composition of these rogue planets plays a crucial role in their ability to retain heat. Rocky planets, with their dense interiors, can hold on to heat from radioactive decay or residual energy from their formation. This internal warmth might create pockets of liquid water or geothermal activity, even in the absence of a star. Gas giants, on the other hand, rely on their thick atmospheres to trap heat, maintaining relatively stable temperatures over long periods. This ability to retain heat is key to their potential habitability, as it could provide the energy needed to sustain chemical processes or even life itself. Interestingly, the size and composition of rogue planets also influence their detectability. Smaller, rocky planets are harder to spot because they emit less heat and reflect little to no light. Gas giants, with their larger size and heat retention, are easier to detect using infrared telescopes. This difference in detectability means that our current understanding of rogue planets might be skewed toward the larger, more visible ones, leaving countless smaller worlds still hidden in the darkness of space. As we explore the diversity of rogue planets, It's clear that their size and composition are more than just details. They're windows into their origins, evolution, and potential to support life. Whether they're frozen rocky worlds or swirling gas giants, each rogue planet tells a unique story about the vast and varied nature of the universe. And as we continue to uncover these stories, we inch closer to understanding the true scope of what's possible in the cosmos. With this in mind, let's turn our attention to another intriguing aspect of these wandering worlds: their moons. Could these celestial companions hold the key to making rogue planets more habitable? That's where our journey takes us next. Now, let's venture into another fascinating dimension of rogue planets: their moons. While these wandering worlds drift alone through the cold expanse of space, many of them might not be entirely solitary. Just as planets in our solar system have moons, rogue planets could also host their own celestial companions. These moons, often overlooked, might hold the key to unlocking the potential for life in the most unexpected places. Imagine a rogue planet, untethered from any star, drifting in eternal darkness. Now, picture a moon orbiting it, caught in a gravitational dance. This moon could experience tidal heating, a process where the gravitational pull of the rogue planet stretches and compresses the moon's interior, generating heat through friction. This internal warmth could create subsurface oceans, much like those believed to exist beneath the icy crusts of moons like Europa or Enceladus in our own solar system. These hidden oceans, shielded from the freezing void of space, might provide stable environments where life could take hold. The presence of moons could transform a rogue planet from a barren, frozen world into a system teeming with potential. Tidal heating isn't just a theoretical concept, it's a phenomenon we've observed in our own cosmic backyard. For example, Jupiter's moon Io is the most volcanically active body in the solar system, thanks to the intense tidal forces exerted by Jupiter. Similarly, Saturn's moon Enceladus spews geysers of water into space, hinting at a subsurface ocean warmed by tidal interactions. If rogue planets have moons, these same forces could be at work, creating pockets of warmth and liquid water in an otherwise inhospitable environment. But what would life on such a moon look like? Without sunlight, any life forms would likely rely on chemosynthesis, a process where organisms derive energy from chemical reactions rather than sunlight. On Earth, we've found such life forms thriving in the deepest parts of the ocean, near hydrothermal vents. These ecosystems, completely independent of the sun, could serve as a model for how life might exist on a moon orbiting a rogue planet. Picture a dark, icy world with a warm, liquid ocean beneath its surface, teeming with microbial life or even more complex organisms adapted to the extreme conditions. The idea of moons as havens for life also raises intriguing questions about habitability. While the rogue planet itself might be too cold or lack the necessary conditions for life, its moons could offer a more stable environment. The gravitational interactions between the planet and its moon could create a dynamic system, with tidal forces driving geological activity and maintaining liquid water over long periods. This makes moons around rogue planets some of the most promising candidates for finding life beyond our solar system. As we explore the possibilities, It's clear that rogue planets and their moons represent a new frontier in our search for life in the universe. These moons, often hidden in the shadows, could be the key to unlocking the mysteries of habitability in the most unlikely places. And as we continue to study these distant worlds, we might just find that life, in all its resilience and adaptability, has found a way to thrive even in the coldest, darkest corners of the cosmos. With this in mind, let's shift our focus to another intriguing aspect of rogue planets, their speed and trajectory. How do these wandering worlds navigate the vastness of space, and what forces shape their journey through the galaxy? That's where our exploration takes us next. Now, let's turn our attention to the incredible journeys these rogue planets undertake as they drift through the galaxy. Unlike planets bound to a star, rogue planets are free-floating, untethered by the gravitational pull of a central sun. But how do they move, and what determines their path through the vastness of space? The answer lies in the complex interplay of gravity and motion that shapes their speed and trajectory. Rogue planets can travel at astonishing speeds, often reaching tens or even hundreds of kilometers per second. These velocities are influenced by the forces that originally ejected them from their star systems. Imagine a planet being flung out of its orbit during a chaotic gravitational encounter, perhaps a close pass with a massive planet or a collision within its system. This violent ejection propels the rogue planet into interstellar space, where it begins its solitary journey. But the story doesn't end there. As a rogue planet drifts through the galaxy, it encounters other massive objects, stars, black holes, and even dense clouds of gas and dust. Each of these interactions can alter its trajectory, bending its path or accelerating its speed. For example, if a rogue planet passes near a star, the star's gravity can act like a slingshot, flinging the planet even faster into the void. Similarly, a close encounter with a black hole could dramatically change its direction, sending it on a completely new course. The galaxy itself also plays a role in shaping the movement of rogue planets. The Milky Way's gravitational field, created by the combined mass of billions of stars, dark matter, and other celestial objects, creates a kind of cosmic highway. Rogue planets, like all objects in the galaxy, are influenced by this overarching gravitational pull, which guides their long-term trajectories. Over millions or even billions of years, these planets may weave intricate paths through the galaxy, sometimes looping around its center or being drawn toward regions of higher density. Interestingly, some rogue planets may even find temporary homes. If a rogue planet passes close enough to a star or a planetary system, it could be captured by their gravity, becoming a new member of that system. While this is rare, it's not impossible. Such an event would dramatically alter the planet's trajectory, turning it from a wanderer into a bound object once again. The speed and trajectory of rogue planets are not just fascinating, they also have implications for their potential habitability. A faster-moving planet might have less time to interact with other objects, reducing the chances of being captured or influenced by external forces. On the other hand, a slower-moving rogue planet might have more opportunities for gravitational interactions, potentially leading to more dynamic and varied paths through the galaxy. As we consider the journeys of these wandering worlds, it's clear that their movement is anything but random. Each rogue planet's path is a testament to the intricate dance of gravity and motion that governs the cosmos. And as we continue to study these enigmatic objects, we gain a deeper understanding of the forces that shape not just rogue planets, but the entire universe. With this in mind, let's now explore another captivating aspect of rogue planets, their prevalence in the Milky Way galaxy. How many of these wandering worlds might exist, and what role do they play in the grand structure of our cosmic home? That's where our journey takes us next. Now, let's shift our gaze to the broader canvas of our galaxy, the Milky Way, and uncover the role rogue planets play within its vast expanse. Just how common are these wandering worlds, and what does their presence mean for the structure and dynamics of our cosmic neighborhood? The answers might surprise you. Scientists estimate that rogue planets could outnumber star-bound planets in the Milky Way by a significant margin. While exact numbers are hard to pin down, some studies suggest there could be billions, or even trillions, of these free-floating worlds drifting through our galaxy. To put that into perspective, for every star in the Milky Way, there might be several rogue planets silently moving through the darkness. This staggering abundance challenges our traditional view of planets as objects tethered to stars, revealing a universe far more dynamic and unpredictable than we once imagined. But how do these rogue planets fit into the larger picture of the Milky Way's structure? Unlike star-bound planets, which are concentrated in the galactic plane, the flattened disk, where most of the galaxy's stars reside, rogue planets can be found throughout the galaxy. They roam not only within the disk, but also in the halo, the sparse outer region that surrounds the Milky Way. This widespread distribution means rogue planets are woven into the very fabric of our galaxy, influencing its gravitational field and contributing to its overall mass. Interestingly, rogue planets may also play a role in shaping the Milky Way's dynamics. Their sheer numbers and widespread presence mean they interact with other celestial objects, from stars to gas clouds, in ways that can subtly alter the galaxy's structure over time. For instance, a rogue planet passing through a dense region of the galaxy might disturb the orbits of nearby stars, or even trigger the collapse of a gas cloud, potentially leading to the birth of new stars. While these effects are small on an individual scale, the cumulative impact of billions of rogue planets could be significant. Moreover, rogue planets might hold clues to the Milky Way's history. Some of these worlds could be ancient relics, ejected from their star systems during the galaxy's turbulent early days. By studying their composition and trajectories, scientists can piece together the conditions that existed when the Milky Way was young, offering a glimpse into the processes that shaped our cosmic home. Yet, despite their prevalence, rogue planets remain elusive. Their lack of a host star makes them incredibly difficult to detect, and much of what we know about them comes from indirect methods like gravitational microlensing. As technology advances, however, we're beginning to uncover more of these hidden worlds, shedding light on their numbers, distribution, and role in the galaxy. As we ponder the abundance and influence of rogue planets in the Milky Way, one thing becomes clear. These wandering worlds are not just cosmic oddities, they are integral players in the grand story of our galaxy. Their presence reminds us that the universe is full of surprises, and that even in the vast emptiness of space, there is always more to discover. With this in mind, let's now turn our attention to an even more intriguing question. Could rogue planets exist beyond the Milky Way in other galaxies? And if so, what might they tell us about the universe as a whole? That's where our exploration takes us next. As we venture beyond the Milky Way, the mystery of rogue planets takes on an even grander scale. Could these wandering worlds exist in other galaxies, drifting through the vast expanses of intergalactic space? The answer, while still shrouded in uncertainty, opens up a fascinating realm of possibilities. If rogue planets are as abundant in other galaxies as they are in our own, they could be a universal phenomenon, weaving their way through the cosmic tapestry on a scale we're only beginning to imagine. But detecting rogue planets in distant galaxies presents a monumental challenge. Unlike within the Milky Way, where we can use techniques like gravitational microlensing to spot these elusive worlds, the sheer distance to other galaxies makes such methods far less effective. The light from rogue planets in other galaxies is incredibly faint, often drowned out by the brightness of stars and other celestial objects. Even with the most advanced telescopes, picking out a rogue planet in another galaxy is like trying to spot a single candle flickering in a city lit by millions of lights. Despite these challenges, scientists are exploring innovative ways to search for rogue planets beyond our galaxy. One promising approach involves studying the gravitational effects these planets might have on the light from distant quasars or other bright objects. As a rogue planet passes in front of such a light source, its gravity could bend and magnify the light, creating a temporary brightening that might be detectable from Earth. While this method is still in its early stages, it offers a glimmer of hope for uncovering rogue planets in the far reaches of the universe. If we were to discover rogue planets in other galaxies, what might they tell us about the cosmos? For one, their presence could shed light on the processes that govern planet formation and ejection on a galactic scale. Are rogue planets more common in certain types of galaxies, such as those with more turbulent histories or denser star populations? Or do they form and drift freely in all galaxies, regardless of their structure or environment? Answering these questions could help us understand how galaxies evolve and how planetary systems are born and disrupted across the universe. Moreover, rogue planets in other galaxies might offer clues about the distribution of dark matter. Some theories suggest that rogue planets could contribute to the universe's missing mass, and studying their numbers and movements in different galaxies might help us map the invisible web of dark matter that holds the cosmos together. This could deepen our understanding of the universe's structure and the forces that shape it on the largest scales. As we ponder the existence of rogue planets in other galaxies, we're reminded of just how much we have yet to learn about the universe. These wandering worlds, whether in our own galaxy or beyond, challenge our assumptions and push the boundaries of what we thought was possible. They remind us that the cosmos is full of surprises, waiting to be uncovered by those who dare to look. With this in mind, let's now turn our attention to the future. What new technologies and missions could revolutionize our search for rogue planets, both within the Milky Way and beyond? And what secrets might these enigmatic worlds reveal as we continue to explore the universe? That's where our journey takes us next. As we look to the horizon of cosmic discovery, the future of rogue planet exploration holds immense promise. New technologies and missions are on the verge of transforming our understanding of these wandering worlds, offering tools that could reveal secrets hidden in the depths of interstellar and intergalactic space. One of the most exciting developments is the next generation of space telescopes, designed to peer deeper into the universe than ever before. Instruments like the James Webb Space Telescope, already revolutionizing our view of the cosmos, are being joined by upcoming observatories such as the Nancy Grace Roman Space Telescope. These telescopes, equipped with advanced infrared capabilities, could detect the faint heat signatures of rogue planets, even those drifting far from any star. But it's not just about seeing farther, it's about seeing smarter. Scientists are developing innovative techniques to enhance our ability to spot rogue planets. For instance, artificial intelligence is being integrated into data analysis, allowing researchers to sift through vast amounts of telescope data more efficiently. This could help identify the subtle signals of rogue planets that might otherwise go unnoticed. Additionally, advancements in gravitational microlensing are being refined, enabling us to detect smaller, Earth-sized rogue planets that were previously beyond our reach. Space probes are also set to play a crucial role in this new era of exploration. Missions like the European Space Agency's Euclid Telescope and NASA's upcoming Nancy Grace Roman Space Telescope are designed to map the universe in unprecedented detail. These missions could uncover rogue planets not only in our own galaxy, but potentially in others as well. By studying the gravitational effects of these planets on light from distant stars, we might even be able to estimate their masses and compositions, providing clues about their origins and potential habitability. Theoretical advancements are equally important in shaping the future of rogue planet research. Scientists are exploring new models to explain how rogue planets form and evolve. Some theories suggest that these worlds could be far more common than we currently estimate, potentially outnumbering star-bound planets in the galaxy. Others propose that rogue planets might harbor subsurface oceans or other environments where life could thrive, challenging our traditional notions of habitability. These ideas are driving the development of new detection methods and inspiring missions that could one day send probes to study rogue planets up close. As we stand on the brink of these breakthroughs, it's clear that the search for rogue planets is entering a thrilling new chapter. With cutting-edge technology, innovative techniques, and bold theoretical ideas, we are poised to uncover the mysteries of these enigmatic worlds. What we learn could reshape our understanding of planet formation, the potential for life beyond Earth, and the very nature of the universe itself. The future of rogue planet exploration is not just about finding new worlds, it's about expanding the boundaries of human knowledge and imagination. And as we continue this journey, one thing is certain: the cosmos still has countless surprises in store for us. As we turn our gaze toward the search for extraterrestrial life, rogue planets emerge as intriguing candidates in this cosmic quest. These wandering worlds, untethered from the warmth of a star, challenge our traditional ideas of where life might exist. While we often think of the Goldilocks Zone around stars as the ideal place for life, rogue planets remind us that habitability might not be confined to such narrow boundaries. Their potential to harbor life lies in the possibility of internal heat sources, such as radioactive decay or tidal forces from moons, which could create subsurface oceans or geothermal environments. These hidden pockets of warmth might offer a refuge for life, even in the cold, dark expanse of interstellar space. Rogue planets also present unique opportunities for future missions aimed at finding extraterrestrial life. Unlike planets orbiting stars, which are often bathed in intense radiation or gravitational forces, rogue planets might offer more stable environments for life to develop. Missions equipped with advanced instruments could one day probe these worlds, searching for signs of microbial life or even more complex organisms. The challenge, of course, is reaching these distant, drifting worlds. But as technology advances, the idea of sending probes to study rogue planets up close becomes less like science fiction and more like a tangible goal. What makes rogue planets particularly fascinating is how they force us to rethink the very definition of habitability. If life can exist on a planet without a star, what does that mean for our search for life elsewhere in the universe? It opens up entirely new possibilities, suggesting that life might be far more widespread and resilient than we ever imagined. Rogue planets could be the key to unlocking some of the universe's greatest mysteries, from the origins of life to the potential for civilizations beyond our own. As we continue to explore these enigmatic worlds, one thing is certain: rogue planets are not just curiosities of the cosmos, they are windows into the boundless possibilities of life in the universe. And as we push the boundaries of our understanding, we may find that the answers to some of our most profound questions lie not in the light of distant stars, but in the darkness between them. Now, let's turn our attention to one of the most elusive aspects of rogue planets: their atmospheres. Unlike planets orbiting stars, where atmospheres can be studied through the light they reflect or absorb, rogue planets present a unique challenge. Without a star's illumination, these wandering worlds are shrouded in darkness, making it incredibly difficult to analyze what lies above their surfaces. The mystery of rogue planet atmospheres is a puzzle that scientists are only beginning to piece together. What little we know comes from indirect methods and educated guesses. Some theories suggest that rogue planets might retain thick atmospheres, especially if they are gas giants. These atmospheres could be composed of hydrogen, helium, and other gases, much like the atmospheres of Jupiter or Saturn. However, without the warmth of a star, these gases might freeze or condense, creating layers of icy clouds or even solid surfaces. On the other hand, smaller, rocky rogue planets might have thinner atmospheres, if they have any at all, as their weaker gravity could allow gases to escape into space over time. One intriguing possibility is that rogue planets could have atmospheres rich in greenhouse gases, like methane or carbon dioxide. These gases might trap whatever internal heat the planet generates, creating a stable environment beneath the surface. This could be especially important for rogue planets with subsurface oceans, as a thick atmosphere might help insulate these hidden bodies of water, keeping them liquid and potentially habitable. Another factor to consider is how rogue planet atmospheres might differ from those of star-bound planets. Planets orbiting stars often experience intense radiation and stellar winds, which can strip away their atmospheres over time. Rogue planets, on the other hand, drift in the relative calm of interstellar space, shielded from such forces. This could mean that their atmospheres, if they exist, might be more stable and long-lasting, offering a unique environment for scientific study. Despite the challenges, scientists are finding ways to probe these mysterious atmospheres. Infrared telescopes, for example, can detect the faint heat signatures emitted by rogue planets, providing clues about their atmospheric composition. Future missions equipped with advanced instruments might one day allow us to study these atmospheres in greater detail, revealing secrets about their origins and potential to support life. The study of rogue planet atmospheres is still in its infancy, but it holds immense promise. By unraveling the mysteries of these dark, drifting worlds, we could gain new insights into the diversity of planetary atmospheres and the conditions that might allow life to thrive in the most unexpected places. As we continue to explore the cosmos, rogue planets remind us that even in the coldest, darkest corners of the universe, there are still wonders waiting to be discovered. Now, let's take a moment to consider how time itself might unfold on a rogue planet. Without a star to mark the passage of days or years, these wandering worlds exist in a state of perpetual darkness, a concept often referred to as eternal night. Imagine a place where the sun never rises, where the sky is an endless expanse of black, punctuated only by the faint glow of distant stars. On such a planet, the very idea of time as we know it becomes almost meaningless. There are no sunrises or sunsets, no seasons to mark the turning of the year. Instead, time flows in a continuous, unchanging stream, shaped not by the rhythms of a star, but by the planet's own internal processes. This eternal night has profound implications for a rogue planet's geology and climate. Without the heat of a star, the surface of a rogue planet would likely be frozen, with temperatures plunging to hundreds of degrees below zero. Yet beneath this icy exterior, the planet's core might still be active, generating heat through radioactive decay or the gravitational pull of a moon. This internal warmth could create pockets of liquid water or even vast subsurface oceans, hidden beneath layers of ice and rock. Over time, these hidden reservoirs might evolve, shaped by the slow, steady forces of geology, rather than the rapid changes driven by a star's energy. The lack of a star also means that rogue planets experience time in a way that's fundamentally different from planets in star systems. On Earth, the cycle of day and night drives everything from weather patterns to the behavior of living organisms. But on a rogue planet, there is no such cycle. Instead, the planet's rotation, if it rotates at all, would determine the length of its day, which could last anywhere from hours to centuries. This slow, unchanging rhythm might create a world where time feels almost suspended, where geological processes unfold over millions of years and life, if it exists, adapts to a pace that's unimaginably slow by our standards. Yet, even in this eternal night, there is potential for life. Some scientists speculate that rogue planets with subsurface oceans could harbor extremophiles, organisms that thrive in extreme environments. These life forms might rely on geothermal energy or chemical reactions rather than sunlight, creating ecosystems that are entirely independent of a star. Over time, these ecosystems could evolve in ways that are completely alien to anything we've seen before, shaped by the unique conditions of a rogue planet's environment. As we ponder the concept of time on rogue planets, we're reminded of just how diverse and mysterious the universe can be. These worlds challenge our understanding of time, life, and the very nature of existence. They invite us to imagine a reality where the rules are different, where the familiar rhythms of day and night are replaced by the slow, steady pulse of a planet drifting through the void. And as we continue to explore the cosmos, rogue planets remind us that even in the darkest corners of space, there are still stories waiting to be told, stories that might one day change the way we see the universe and our place within it. As we look toward the distant future of the universe, rogue planets take on an even more intriguing role. Picture this: billions of years from now, as stars burn out and galaxies fade into darkness, these wandering worlds may become some of the last bastions of existence in an ever-expanding cosmos. Without the light of stars, the universe will grow colder and darker, but rogue planets, drifting silently through the void, could persist long after the stars have vanished. Their isolation, once seen as a curse, might instead become their greatest strength. The fate of rogue planets is deeply tied to the fate of the universe itself. As the cosmos continues to expand, the distances between celestial objects will grow unimaginably vast. Stars will exhaust their fuel, leaving behind remnants like white dwarfs, neutron stars, and black holes. Over time, even these remnants will cool and fade, leaving the universe a colder, emptier place. Yet rogue planets, untethered from any star, could continue their solitary journeys, unaffected by the death of stellar systems. Their resilience lies in their independence. They don't rely on a star's energy to survive, and their internal heat sources could keep them active for eons. This raises a fascinating question. Could rogue planets be the last refuge for life in the universe? In a cosmos devoid of stars, where light and warmth are scarce, these planets might still harbor life in their subsurface oceans or geothermal environments. Extremophiles, or even more complex organisms, could adapt to the eternal darkness, relying on chemical energy or tidal forces from moons to sustain themselves. Over unimaginable timescales, life on rogue planets might evolve in ways we can scarcely imagine, creating ecosystems that are entirely self-sufficient and independent of sunlight. But the story doesn't end there. As the universe continues to expand, even rogue planets will face challenges. The relentless pull of dark energy will drive galaxies farther apart, and the fabric of space itself will stretch thinner. Over trillions of years, rogue planets might find themselves drifting in an increasingly empty void, with no stars or galaxies to guide their paths. Yet, even in this cold, dark future, these worlds could remain as silent witnesses to the universe's final chapters, a testament to the enduring nature of existence. The idea of rogue planets as the last remnants of life in a dying universe is both humbling and awe-inspiring. It challenges us to rethink our understanding of life's resilience and the conditions necessary for survival. While the fate of the universe may seem bleak, rogue planets remind us that even in the darkest corners of space, there is potential for life to endure. They invite us to consider the possibility that life, in some form, might outlast the stars themselves, carrying the spark of existence into the far reaches of time. As we ponder the long-term fate of rogue planets, we're reminded of the vastness of the cosmos and the mysteries that still lie ahead. These wandering worlds, once thought of as lonely and desolate, might one day become the last hope for life in a universe that has long since moved on. And as we continue to explore the cosmos, rogue planets stand as a reminder that even in the face of an uncertain future, the universe is full of surprises waiting to be discovered, waiting to be understood. Now, let's turn our gaze closer to home and imagine what it might be like for humans to one day visit a rogue planet. Picture this, a spacecraft carrying a crew of explorers venturing into the vast, uncharted darkness of interstellar space. Their destination, a rogue planet, a world untethered from any star, drifting silently through the void. The journey alone would be a monumental challenge, spanning distances so vast that even light would take years to traverse. But the rewards of such a mission could be equally extraordinary, offering us a glimpse into one of the universe's most enigmatic phenomena. The first hurdle would be the sheer distance. Rogue planets, by their very nature, are isolated, often located far from any star system. Traveling to one would require advanced propulsion technologies, capable of sustaining a crew for decades, if not centuries. Even with the most advanced spacecraft, the journey would test the limits of human endurance and ingenuity. The crew would need to rely on closed-loop life support systems, renewable energy sources, and perhaps even hibernation technology to survive the long voyage. Once they arrived, the challenges would only multiply. A rogue planet, devoid of a star, would be shrouded in perpetual darkness. Without sunlight, the surface would be bitterly cold, with temperatures plunging to hundreds of degrees below zero. Any human explorers would need to rely on artificial light and heat sources, as well as heavily insulated habitats to protect them from the extreme environment. The lack of sunlight would also make it difficult to generate energy, requiring innovative solutions like nuclear power or geothermal energy extraction. But the challenges don't end there. Rogue planets are often subject to intense gravitational forces, especially if they pass near stars, black holes, or other massive objects. These forces could create unstable environments, with shifting landscapes, volcanic activity, or even tidal heating from moons. Navigating such hazards would require precise planning and advanced technology, as well as the ability to adapt to unexpected conditions. Yet, despite these challenges, the potential rewards of exploring a rogue planet are immense. These worlds could hold clues to the origins of planetary systems, the nature of interstellar space, and even the possibility of life beyond Earth. Subsurface oceans, heated by internal radioactivity or tidal forces, might harbor microbial life or even more complex organisms. Studying these environments could revolutionize our understanding of biology and the conditions necessary for life to thrive. Moreover, a mission to a rogue planet would push the boundaries of human exploration, inspiring new technologies and expanding our horizons. It would remind us of our capacity to overcome seemingly insurmountable obstacles and our unquenchable curiosity about the universe. While the journey would be fraught with challenges, the opportunity to set foot on a world without a star would be a historic achievement, marking a new chapter in our quest to understand the cosmos. As we consider the possibility of human exploration of rogue planets, we're reminded of the boundless potential of human ingenuity and the enduring spirit of discovery. These wandering worlds, once thought of as distant and unreachable, might one day become the next frontier for exploration, a testament to our relentless drive to explore the unknown and uncover the secrets of the universe. Now, let's shift our perspective and consider how rogue planets might fit into one of the most famous equations in the search for extraterrestrial life, the Drake Equation. This equation, formulated by astronomer Frank Drake in the 1960s, is a way to estimate the number of intelligent civilizations in our galaxy. It takes into account factors like the rate of star formation, the fraction of stars with planets, and the likelihood of life developing on those planets. But here's the question: where do rogue planets fit into this equation? Should they even be included? Traditionally, the Drake equation focuses on planets orbiting stars, since these are the worlds we've long assumed could support life. But rogue planets challenge that assumption. These wandering worlds, untethered from any star, might still have the potential to harbor life, especially if they have internal heat sources like radioactive decay or tidal forces from moons. If we consider the possibility of life on rogue planets, the equation's outcome could change dramatically. After all, rogue planets are thought to vastly outnumber star-bound planets in the Milky Way. Some estimates suggest there could be billions of them. Including them in the equation could significantly increase the estimated number of habitable worlds in our galaxy. But it's not as simple as just adding rogue planets to the mix. The Drake equation relies on probabilities, and we still know very little about the conditions necessary for life to exist on a rogue planet. For example, how common are subsurface oceans or geothermal activity on these worlds? Could life survive in such extreme environments over billions of years? These are questions scientists are still grappling with, and until we have more data, it's difficult to say how much rogue planets might influence the equation's results. That said, the very idea of including rogue planets in the Drake equation opens up exciting new possibilities. It challenges us to think beyond the traditional concept of the habitable zone, the region around a star where liquid water can exist on a planet's surface. Rogue planets remind us that life might find a way in the most unexpected places, even in the cold, dark depths of interstellar space. By expanding our search to include these wandering worlds, we might discover that the universe is far more teeming with life than we ever imagined. So, should rogue planets be included in the Drake equation? The answer isn't clear-cut, but their potential to host life makes them impossible to ignore. As we continue to explore these enigmatic worlds, we may find that they hold the key to answering one of humanity's oldest questions. Are we alone in the universe? For now, rogue planets remain a tantalizing mystery, one that could reshape our understanding of life's possibilities and our place in the cosmos. Now, let's turn our attention to another profound question that rogue planets might help us answer: the Fermi Paradox. Named after physicist Enrico Fermi, this paradox asks a simple yet haunting question. If the universe is so vast and filled with potentially habitable worlds, why haven't we encountered any signs of extraterrestrial civilizations? Rogue planets, with their unique characteristics, might hold a piece of this cosmic puzzle. One possibility is that life on rogue planets could exist in ways we've never considered. These worlds, drifting in the cold void of space, might not rely on sunlight or the traditional habitable zone to sustain life. Instead, they could harbor life deep beneath their surfaces, powered by internal heat or geothermal energy. If civilizations evolved on such planets, they might remain hidden from us, not because they don't exist, but because their environments are so radically different from what we're used to looking for. Imagine a civilization thriving in the perpetual darkness of a rogue planet's subsurface ocean, completely isolated from the rest of the galaxy. Such a scenario could explain why we haven't detected them. They might not be sending signals into space or building structures that we can observe from Earth. Another angle to consider is the sheer number of rogue planets in the galaxy. If, as some estimates suggest, there are billions of these wandering worlds, it's possible that many of them could host life. But if that life is confined to subsurface environments or lacks the technology to communicate across interstellar distances, it might remain invisible to us. This could mean that the universe is teeming with life, but much of it exists in forms or places we're only beginning to understand. Rogue planets, in this sense, could be the ultimate cosmic hideouts, sheltering civilizations that have no need, or no means, to reach out to the stars. There's also the question of time. Rogue planets, untethered from stars, might experience time differently, without the predictable cycles of day and night, or the influence of a star's lifespan. Civilizations on these worlds could evolve at a pace that's entirely alien to us. They might rise and fall over billions of years, their existence fleeting and difficult to detect. If we're searching for civilizations that exist on a timescale similar to ours, we might be missing those that operate on a completely different rhythm. So, could rogue planets help solve the Fermi Paradox? They certainly offer intriguing possibilities. By expanding our search to include these enigmatic worlds, we might discover that the apparent absence of extraterrestrial life isn't an absence at all. It's simply a matter of looking in the right places. Rogue planets challenge us to rethink our assumptions about where and how life can exist, and in doing so, they might bring us closer to answering one of the universe's greatest mysteries. As we continue to explore these wandering worlds, we may find that the silence of the cosmos isn't as empty as it seems. It's just waiting to be understood. Now, let's venture into a realm that stretches the boundaries of our imagination, the multiverse. Could rogue planets, those solitary wanderers of our universe, play a role in a cosmos that extends far beyond what we can see? The idea of a multiverse, where countless universes exist alongside our own, opens up fascinating possibilities for these drifting worlds. In a multiverse scenario, rogue planets might serve as more than just isolated bodies in the void. They could act as bridges or pathways between different universes. Picture this: a rogue planet, untethered from any star, drifting through the fabric of space-time. In a multiverse, such a planet might encounter regions where the boundaries between universes are thin, allowing it to cross over into entirely different cosmic landscapes. These wandering worlds could become cosmic travelers, moving not just through space, but through dimensions we can barely comprehend. But what would these rogue planets look like in other universes? The laws of physics, the composition of matter, even the nature of time itself might differ drastically from one universe to another. A rogue planet in one universe could be a frozen, lifeless rock, while in another, it might be a vibrant, energy-rich world teeming with forms of life we can't even imagine. The multiverse could host rogue planets that defy everything we know about planetary science, existing in environments where the rules are rewritten entirely. Another intriguing possibility is that rogue planets might not just bridge universes, they could also serve as markers or signposts. In a multiverse, where the sheer number of universes makes navigation nearly impossible, rogue planets could act as natural landmarks. Their unique trajectories and characteristics might help hypothetical travelers, or even advanced civilizations, navigate the complex web of universes. Imagine a rogue planet with a distinct gravitational signature or an unusual composition, acting as a beacon in the vast, interconnected expanse of the multiverse. Of course, all of this remains speculative. The multiverse is still a theoretical concept, and rogue planets are already challenging enough to study within our own universe. But the idea of these worlds existing in a multiverse adds another layer of mystery to their already enigmatic nature. It invites us to think beyond the limits of our current understanding and consider the possibility that rogue planets might be far more than just lonely wanderers. They could be key players in a cosmic drama that spans not just galaxies, but entire universes. As we ponder the role of rogue planets in a multiverse, we're reminded once again of how much we have yet to discover. These worlds, so often overlooked, might hold clues to some of the most profound questions about the nature of existence itself. And while the multiverse remains a realm of theory and imagination, rogue planets give us a tangible connection to the infinite possibilities that lie beyond the stars. Now, let's shift our gaze to a question that has captivated scientists and dreamers alike. Could rogue planets be the key to finding Earth 2.0? For decades, the search for habitable worlds has focused on planets orbiting stars, particularly those within the so-called Goldilocks Zone, where conditions might be just right for liquid water and potentially life. But rogue planets, untethered from any star, challenge this traditional approach. Could these wandering worlds offer an alternative path in our quest for a second Earth? The idea of a rogue planet hosting life might seem far-fetched at first. After all, without a star to provide warmth and light, how could such a world sustain the conditions necessary for life as we know it? But nature has a way of surprising us. Rogue planets might not rely on sunlight for energy. Instead, they could draw heat from within, powered by radioactive decay or tidal forces from moons. These internal heat sources could create subsurface oceans, hidden beneath layers of ice or rock, where life might thrive in ways we're only beginning to understand. Imagine a rogue planet with a thick, insulating atmosphere trapping heat from its core. Beneath its icy surface, vast oceans could stretch for miles, teeming with microbial life or even more complex organisms. Such environments wouldn't need sunlight. They'd rely on geothermal energy, much like the hydrothermal vents found deep in Earth's oceans. These vents support entire ecosystems in complete darkness, proving that life can flourish in the most unexpected places. Could rogue planets harbor similar ecosystems, hidden away from the cold void of space? But the potential of rogue planets goes beyond just the search for life. They might also be candidates for future colonization. While the lack of sunlight presents challenges, it also offers unique advantages. A rogue planet wouldn't be subject to the intense radiation or gravitational stresses of a star system. Its isolation could make it a stable, if unconventional, home for future explorers. Advanced technology, such as fusion reactors or geothermal energy systems, could provide the necessary power to sustain human settlements. And with no star to dictate day and night cycles, life on a rogue planet could follow rhythms entirely of our own making. Of course, the challenges of reaching and colonizing a rogue planet are immense. These worlds drift through the vast emptiness of space, often far from any star system. The distances involved would require breakthroughs in propulsion technology and long-term life support systems. But as we push the boundaries of what's possible, rogue planets remind us that the universe is full of possibilities we've yet to fully explore. In the search for Earth 2.0, rogue planets represent a bold new frontier. They challenge us to rethink our assumptions about habitability and expand our vision of what a home in the cosmos might look like, whether as havens for life or stepping stones for human exploration. These wandering worlds invite us to dream bigger and venture further into the unknown. And as we continue to explore the mysteries of the universe, rogue planets stand as a testament to the boundless creativity of nature and the endless potential for discovery. As we venture deeper into the mysteries of rogue planets, we're reminded of just how vast and enigmatic the universe truly is. These wandering worlds, untethered from stars and drifting through the cosmic void, challenge our understanding of what's possible. They force us to confront the limits of human knowledge and the humbling reality that, despite all our advancements, there's still so much we don't know. Rogue planets are a testament to the universe's boundless creativity and a reminder that our quest for understanding is far from over. Think about it. For centuries, we've looked to the stars for answers, assuming that planets must orbit suns to be significant. But rogue planets defy that assumption, showing us that the universe operates on rules we're still deciphering. They invite us to question our assumptions and expand our thinking. What else might be out there, waiting to be discovered? What other cosmic surprises lie beyond the reach of our current understanding? Rogue planets don't just challenge our science, they challenge our imagination. This journey into the unknown also teaches us something profound about humility. No matter how much we learn, the universe always has more to reveal. Rogue planets, with their solitary existence and mysterious origins, remind us that we're just beginning to scratch the surface of cosmic knowledge. They humble us, showing that even our most advanced telescopes and theories can't yet fully explain their secrets. And yet, this humility isn't discouraging, it's inspiring. It fuels our curiosity and drives us to keep exploring, to keep asking questions, and to keep pushing the boundaries of what we think is possible. Curiosity, after all, is at the heart of every great discovery. Rogue planets spark that curiosity in a way few other celestial objects can. They're a blank canvas for our imaginations, inviting us to dream up new possibilities and rethink what we know about habitability, life, and the nature of planets themselves. What if life exists in ways we've never considered? What if rogue planets hold clues to the origins of the universe? These questions don't just belong to scientists, they belong to all of us, as we collectively ponder our place in the cosmos. And that's the beauty of rogue planets. They remind us that the quest for knowledge is endless. Every discovery leads to new questions, and every answer reveals new mysteries. They show us that the universe is far more complex and wondrous than we can fully grasp, and that's what makes exploration so thrilling. Rogue planets aren't just objects of scientific study. They're symbols of the human spirit's unyielding desire to explore, to understand, and to connect with the cosmos. So, as we reflect on these wandering worlds, let's embrace the lessons they offer. Let's approach the universe with humility, curiosity, and an open mind. Let's remember that the limits of our knowledge aren't barriers. They're invitations to keep learning, keep dreaming, and keep reaching for the stars. Because in the end, it's not just about finding answers. It's about the journey of discovery itself and the endless wonder that comes with it. Now, let's take a step back from the science and venture into the realm of stories and imagination. Rogue planets, with their mysterious and solitary nature, have long captured the human imagination, even before we had the tools to detect them. Throughout history, cultures around the world have woven tales of wandering celestial bodies, often imbuing them with symbolic meaning or supernatural significance. These myths and legends, passed down through generations, offer a fascinating glimpse into how humanity has grappled with the unknown and how rogue planets might have quietly inspired some of these stories. Consider the ancient Greeks, who told tales of Phaeton, the son of the sun god Helios. Phaeton's reckless attempt to drive his father's chariot across the sky caused chaos, nearly setting the earth ablaze before Zeus intervened, striking him down. Some interpretations suggest this myth could reflect an early fascination with celestial wanderers' objects that disrupt the natural order, much like rogue planets drifting unpredictably through space. While the Greeks didn't know about rogue planets as we do today, their stories reveal a deep curiosity about the cosmos and its potential for chaos and wonder. Similarly, in Norse mythology, there's the story of Nidhogg, a serpent that gnaws at the roots of Yggdrasil, the world tree. This cosmic serpent is often associated with destruction and the unknown, much like the way rogue planets exist in the dark, uncharted regions of space. These myths, while not directly about rogue planets, echo the themes of isolation, mystery, and the vastness of the universe that these wandering worlds embody. Even in more recent folklore, we can find echoes of rogue planets. In the 19th century, tales of ghost ships and phantom islands captured the public's imagination. These stories often featured vessels or lands that appeared out of nowhere, only to vanish just as mysteriously. While these tales were rooted in maritime lore, they share a striking resemblance to the way rogue planets appear and disappear in the vastness of space, detectable only through fleeting glimpses and indirect methods. What's truly fascinating is how these ancient stories and modern science intersect. Today, we know that rogue planets exist, drifting through the galaxy without a star to call home. Yet, in many ways, they remain as enigmatic as the mythical wanderers of old. The parallels between these ancient tales and our current understanding of rogue planets remind us that humanity's fascination with the unknown is timeless. Whether through myth or science, we've always sought to make sense of the cosmos and our place within it. These stories also highlight something profound about human nature, our ability to find meaning in the mysterious. Rogue planets, with their solitary journeys and elusive nature, continue to inspire awe and curiosity, much like the celestial wanderers of myth. They remind us that the universe is full of wonders waiting to be discovered, and that sometimes the line between science and storytelling is thinner than we might think. As we reflect on these connections, it's worth asking what other myths and legends might have been inspired by cosmic phenomena we're only now beginning to understand. Could rogue planets have been the unseen muses behind other ancient tales? The answers may remain hidden, but the questions themselves are a testament to the enduring power of curiosity and the timeless allure of the unknown. As we bring our journey through the mysteries of rogue planets to a close, let's take a moment to reflect on what we've uncovered. These wandering worlds, untethered from the warmth of a star, drift silently through the vast expanse of space, embodying the very essence of cosmic mystery. From their origins, whether ejected from star systems or born in the cold depths of interstellar space, to their potential to harbor life in the most unexpected ways, rogue planets challenge our understanding of what it means to be a planet. They remind us that the universe is far stranger and more wondrous than we often imagine. We've explored how rogue planets have inspired myths and legends across cultures, from the ancient Greeks to Norse mythology, and even into modern folklore. These stories, though rooted in imagination, reveal a deep human fascination with the unknown, a fascination that continues today as we uncover more about these enigmatic worlds. We've also delved into the science behind their discovery, from the groundbreaking use of gravitational microlensing to the role of infrared telescopes in spotting these faint, heat-emitting objects. Each discovery brings us closer to understanding these solitary wanderers, yet they remain shrouded in mystery. But perhaps the most intriguing question of all is this: what else lies hidden in the darkness of space, waiting to be discovered? Rogue planets remind us that the universe is vast, filled with secrets we've only begun to uncover. They challenge us to rethink our assumptions about habitability, life, and the very nature of existence. Could these wandering worlds hold the key to understanding our place in the cosmos? Or are they simply one more piece of an infinite puzzle, urging us to keep exploring, keep questioning, and keep dreaming. As we gaze up at the night sky, let's remember that every star, every planet, and every rogue world tells a story of creation, destruction, and the endless dance of the cosmos. And perhaps, in the quiet solitude of a rogue planet, drifting through the void, we might find a reflection of our own journey, searching, wandering, and forever reaching for the unknown. So, as we conclude, here's a question to ponder. In a universe filled with infinite possibilities, what other wonders are waiting to be discovered, and what might they teach us about ourselves and the cosmos we call home? If you've enjoyed this exploration of rogue planets, don't forget to like, subscribe, and hit the notification bell to join us on our next cosmic adventure. Until then, keep looking up. The universe is full of stories, and the best ones are yet to be told. you.